Barium chloride is an inorganic compound. It is a water-soluble salts of barium, which makes it very toxic. This makes it very difficult for the amateur chemist to buy it in the European Union. Although it is not prohibited, it is not very likely that anyone sells it to a stranger without any proper education. Luckily, the minor toxic barium carbonate can be bought in the European Union without any restrictions. Also, hydrochloric acid can be bought freely. We can react barium carbonate and hydrochloric acid to form barium chloride and CO2. Barium carbonate was used as a rodenticide in the past, so take proper precautions. Barium chloride is very poisonous. 1 to 4 grams can kill an adult. Let's start with our barium chloride preparation. First, I take my barium carbonate. This one I bought on Amazon, but there are several other sellers in the EU as well. Then I take hydrochloric acid. In this case, I take 40 milliliters of approximately 32% hydrochloric acid. I let the barium carbonate react with the hydrochloric acid by just putting both compounds together in a beaker. This reaction is highly exothermic and produces a lot of CO2 gas, which can let the solution foam over. Also be aware that this reaction can produce toxic gases and barium chloride particles in the air. When the pH of the solution is neutral, I stop adding barium carbonate. First, I thought about cleaning up the product by filtering and recrystallization. Another approach would be dropping the product out of solution with a fitting solvent. So I prepared a stirrer and added some distilled water to my solution, because not all of the product has been dissolved. But in reality, I don't need a super pure product, and I really don't mind some minor contamination with barium carbonate and traces of whatever impurities were in the barium carbonate in the beginning. So I decided to just evaporate off the water and then collect the salt. I used a big Petri dish to generate a bigger surface to speed up the evaporation. Please keep in mind that this produces toxic particles of barium chloride in the air. Barium chloride is also toxic to inhalation. Also keep in mind that this technique is very sloppy and tend to splashing the toxic product all over the place. Here is our crude and dry product. Let's have a look of how much it is. Nearly 36 grams. That is way more than I will ever need. But on the other hand, it's always good to have some in reserve. Now we only need to test it and to verify that we actually have barium chloride. Barium chloride can be used to identify the presence of sulfate ions in a solution, because it produces insoluble barium sulfate, which participates out and renders the solution milky and opaque. I test the barium chloride against ammonium nitrate that I extracted from Ammonium Sulfate salpeter in video 1. Furthermore, I test it against the residue from the extraction, which should be mostly ammonium sulfate. At last, I take copper sulfate. For each test, I solve 2 grams of the corresponding salts in 20 milliliters of distilled water. In the small beaker is a saturated solution of barium chloride in distilled water. Let's have a closer look when we start with the copper sulfate solution. If all went good, we should see white clouds forming in the solution while I am dropping in the barium chloride. Here we go. We can see a white precipitate, which means we actually have produced barium sulfate. This confirms our initially produced barium chloride product. Now the ammonium sulfate solution. Again, we see a white precipitate which indicates sulfate ions in the solution. The last candidate is the ammonium nitrate solution with the ammonium nitrate that I extracted from ASS in video number 1. We should see no precipitate when the extraction was successful. And indeed, no precipitate. This is a strong indicator that the extraction in video number 1 was a success.